Um, Hello everyone. Today, as I promised, we will talking about oxidation reduction in organic molecules. So before we start these topics for organics, at first we need to recognize what's mean originally oxidation and originally what mean reduction. Many years ago, people live badly until they recognize method of production of iron. They use iron oxide. If iron oxide mixed with carbon and heated, we get iron and carbon dioxide, and let's balancing from 1 not working to 6 3 3 3, and they name its process as reduction. Originally they have something not very important, use iron ore, but then they got something useful, and originally this process named as reduction. Then after this process, people realize one bad process. If we left on air iron, and iron will react with oxygen, and this oxygen produce back again iron oxide, and if we put 1, we can't balance in. If we put 2, it means here 3, here 4. So originally, many years ago, scientists find if we produce iron, this process named as reduction, and if we change direction this process in back directions, this process scientists name as oxidation. So originally, oxidation is a process with oxygen, and reduction is process with opposite with oxidation. And any process which like process with oxygen will be named oxidation, and any process like process with carbon, it's reduction. So it's originally meaning. And if we're talking about this process for organic molecules, it will be same. For example, we have methanol, for example, and under some catalyzer we can add O square brackets mean it's not literally oxygen, it's some oxidized agent. O in square brackets, we can produce OO plus H2O. So for compounds with carbon, before reaction was 1 CO bond, after reaction was 2 CO bond. And this process actually is main reason why ethanol deadly, because it's toxic. Another example for reduction, if we have example it's acetaldehyde or ethanol. It's a product of metabolism of alcohol in our body, and it's also toxic, and actually it's main reason why alcohols is toxic, not alcohols itself, but these molecules toxic. We produce ethanol. So before reaction we have 2 CO bond, and after reaction we have only 1 CO bond. So oxidation for organic compounds, it's when number of carbon-oxygen bond increase, and reduction, it's when number of carbon-oxygen bond decrease. So I think it's simple. Another process, for example, let's discuss, for example, it's inorganic compound. It's very famous. It's water production. So this process, it's if we look from left to right, it's oxidation of hydrogen. In same moment, this process, it's reduction for hydrogen in water. So any real chemical process, it's reduction and oxidation in the same moment. So for some elements it's oxidation, for some elements it's reduction. As I say, ethanol, it's these molecules, or if we draw structure more detail, at the present enzyme is called 1,1,1,1. It's alcohols dehydrogenase. We get CH3COH. We have one OH bond. Now we have CO. Now before reaction we have one CO bond. After reaction we have 2 CO bond. It's oxidation. And for oxidation, we can oxidize only one type of bond. If we're talking about organic compounds, it's CH. If we have CH bond, we can oxidize this bond. If no CH bond, we can't. And this bond must be nearby functional groups. So, for example, oxidation of propan-to-ol. It's propan-to-ol or isopropanol. If we draw structure more detail, this bond can be oxidized, and as the present some oxidized agent, it's transformed into this compound, and additionally water produced. And as we see before, CH3OH, at the present same enzymes, CH2CO plus water. All these compounds contain ethanol, have CH bond. Propanol have CH bond. Methanol have also CH bond. Any carbon which bonded with hydrogen, which bonded with another oxygen, can be oxidized. So if we're talking about alcohols, we can oxidize this type of alcohols, this type of alcohols, but if we're talking about this type of alcohols, no, because here no CH. So oxidation, it will be oxidized here. For these compounds, it will be oxidized here and here. And no excuse for aldehydes. If aldehydes is compound with COH groups, and if we add oxygen, we get COOH. So any bond, any CH bond, CHO, these fragments can be oxidized. So if carbon bonded with oxygen and in same moment bonded with hydrogen, it doesn't matter how a structure looks like, but carbon with hydrogen and with oxygen. In this case, carbon bonded with hydrogen can be oxidized, even if compounds are aromatics. In aromatic, it's more complicated mechanism, but principle same. So if we look, for example, for glucose, it's one of main important source of energy in our body. We produce a lot of energy, and actually this energy helped me be here and make this lesson. So if we're talking about glucose, we have 6 oxygen before reaction, and after reaction we have much more oxygen atoms, so number of carbon oxygen groups increase. So if we discuss more deeply oxidation of glucose, it's go into multiple steps. We do not show mechanism of reaction itself because it's quite complicated. But main reason, number of for example, here we have 6 oxygen. It's not shown by structure, but actually in final structure number of carbon oxygen bond more. And here if we look also increase, for example, in glucose oxidize in our organism in 3 steps. First, glycolysis, it's when glucose broken into part, it's pyruvate. Second step, it's pyruvate go to acetyl-CoA, and in this case it's also produce energy. And last step, it's Krebs cycle. And in each 3 steps we produce of energy, and in each 3 steps we increase number of carbon oxygen bond, and In glycolysis, we have little bit ATP. It's most important energy units, most important way of storage energy in our body, and not age. And it's energy. It's already energy. If we're talking about oxidation, production at acetyl-CoA, it's not produce energy directly. It's produced just, manner of speaking, it's hydrogen, conservate hydrogen, and in Krebs cycle we produce a lot of ATP. But if we have complicated organism, ATP itself it's energy, and conservated hydrogen can be converted in ATP also. So it's most important oxidation process, and in this process number of CH bond decrease, and number of CO bond increase. So in final products we have only carbon dioxide, where each carbon bonded by 4 bonds with oxygen. But originally main structure in glycols it's COHCC. So in glucose typically average atom of carbon bonded with 1 bonds with oxygen, but in final products it's go and form 4 bonds. So in glucose it's big molecules, each atoms averagely in average have 1 CO connections. In final products we have 4 CO connections. So oxidation it's a process where number of bonds with oxygen increase. So if we look deeply and some review, originally oxidation it's oxidation is process when we react with oxygen, and originally reduction is process where we remove oxygen. In organic compounds it's same. Any oxidation process it's when number of carbon oxygen bond increase, and if number of carbon oxygen bonds decrease, we name this process it's reduction. And any oxidation process, if we change direction, if we for example from these molecules try to get these molecules, it will be oxidation of formaldehyde, but oxidation methanol. So oxidation it's what's happened with substance what we're interested in, because actually for example oxidation of iron, what's shown here, it's a process of reduction of oxygen. But in organic chemistry we typically focus about what substance more complicated, and in this case I think more complicated it's organic molecules. So if we're talking about organic molecules, only 1 fragments of molecules can be oxidized if carbon bonded with hydrogen and at same moment bonded with oxygen. If this structure present, it will be work, it will be oxidized, and by this way ethanol has these fragments, and 1 CO bond transform into 2 CO bond. Isopropanol, what we use as ethanol replacement, especially in country where people like drink any liquids which contain ethanol, include my country, it's big problem, and it's bad. Methanol have CH bond, which bonded with O, so it can be oxidized. So any alcohols or aldehydes. Any structure which contains CH which bonded with CO can be oxidized. So some alcohols can be oxidized, but not all. For example, if alcohols alcohols molecules contain these fragments where OH group bonded with carbon, which bonded with 3 carbons, no CH, and it's mean no oxidation. And if we're talking about aldehydes, they can also oxidize because they have CH bond with atom of carbon which bonded with O. So if we generalize these fragments, it's necessary part for any oxidation process. And if a number of carbon-oxygen bond increase, it's oxidation. Its number of carbon-oxygen bond decrease, it's reduction. It's probably all what I'm planning to do. Very soon, on this weekend, I will make not webinar. I will start make a short video, and I will be upload into TikTok. So it will be 1 minute video about oxidation, 1 minute video about nomenclature. So it's if someone planning to quick preparing, I think it will be useful. So don't forget like or comments about my job, and if you have any suggestions, just message me. So thank you for listening, subscribe, share, and see you later. Bye.